After applying the boundary conditions, let us move ahead to the loads. That is the next tab in MIDAS Gen, loads. Let me explain you about the applicable loading conditions in MIDAS Gen. We have static loads that contain the structural loads, lateral loads, beam loads, pressure loads. Under the pressure loads, best part is about the hydrostatic pressure loads. Automatically the triangular loads are applied, and the floor loads. Then under the dynamic loads, we have got response spectrum data and time history analysis data. We can also perform temperature analysis in MIDAS Gen. So here you can see the temperature loads. We can as well perform post-tensioning by using pre-stress loads. Under the construction stages, we have automatic construction stage wizard for building structures. This will cater to the column shortening effect. Under the moving loads, we have got various moving load data. As a result, the software can provide you with the location of the vehicle for a particular node for maximum force, or maximum force at that particular node. Going to the heat of hydration, if you have mass concreting, like if the depth of the raft foundation is more than 1 meter, then you have to go for heat of hydration analysis. The best part in the software is you can include the pipe cooling system to cater to the cracking occurring because of the hydration. We can as well apply the settlement loads, and there are loads table. In this workshop, we are going to perform the static loads and the dynamic loads under which response spectrum will be shown. Static loads. The first thing that we do for static loads is create load cases. These load cases are important for creating the load combinations automatically. So firstly, I'll have a load case for the self-weight of the structure. The type will be dead load. I'll click on add. I'll have another load case named dead load for my floor finishes or any other loads. I'll click on add. Live load. The type here changes to live load and add. I'll apply wind load in X direction. Wind load on structure is the type. Add. I'll also add in the Y direction. I'll add load case for earthquake in X direction, and also in the Y direction. That's all. My load cases are created. Now I'll close this dialog box and move ahead to the next command, that is self-weight. So the self-weight with the load case name as SW, I'll provide a scale factor in the Z direction. So that will be minus, that is downward, and 100%, that is 1. So my scale factor is -1 in the Z direction for the self-weight. And I'll click on add, and our self-weight has been successfully added to the structure. Next, I will go ahead. I'm going from left to right as per the workflow. So I'll convert loads to masses for my seismic analysis. So as per UBC 97 clause 1631.1, I have to consider 100% of the self-weight, 100% of the dead load, and a part of live load. That is, I'll take 0.25 here. I'll click on add and click on OK. After that, let us go ahead to the lateral loads, under which I'll begin with the wind loads. So wind loads I'll add, and we have a huge database codes available for automatic calculation of wind loads. So we are going to be using over here IBC 2012, which is ASCE 710 2010. Here two methods are available, alternate and directional procedure. So we'll be using directional procedure here. The basic wind speed is in miles per hour. So if you have the data in kilometers per hour, then you can simply use that kilometers per hour and multiply it with the factor, scale factor, that is 0.63 to convert from kilometers to miles. Exposure category, I'm keeping it as C for flat roof, for flat country. Mean roof height 67, taken by the software directly. Then directional factor, by default it is 0.85 as per the code. And then further I'm going to consider the rigid structure. This is my rigid structure. So the gust factor will be calculated either manually and provided over here, or the software has the calculator for the gust factor effect. So the software has automatically taken the breadth in the X and the Y direction, and upon clicking on calculate, the software has calculated the gust factor in X as well as Y direction. I'll click on OK. So here we have the gust factor effect. Further, we can also create a load, evaluate the load by using the force coefficients by checking this on. Then we have wind eccentricities. Now as per ASCE 7 table number, figure number 27.4, there are 11 cases that you have to create. So those 11 cases are dependent on the scale factor, that is application in the X and Y direction, as well as the wind eccentricities, positive, negative in the X and Y direction. So we can create load cases, different number of load cases, and provide the combinations using these options available. To make it quick, if you want, we can provide you with a MIDAS gen text file which can be edited quickly. The gust factor effect can be quickly edited, and then by using MIDAS mgt command shell we can create those load cases very quickly. So here wind eccentricity, I'm considering it as none. I'm considering the case 1 only, wherein I can have 100% of X direction only. I'll click on apply, and 100% of Y direction only. So here when I create my load evaluation case, I can see what is the story forces, story shears by clicking on this wind load profile. Story force graph, story shear graph, and overturning moment graph is created automatically before analysis. These are the values. And not only that, the software is not a black box. It can show you the calculations it has done. So if you click on make wind load calculation sheet, you can see that the software has provided with the formulae it has used. These are the parameters we have provided and all the values calculated in a tabular format. So this is a text file which you can select and copy and paste it into your reports. These graphs can also be taken as images from here. Dynamic report chart image. I'll click on OK to close this dialog box. Sorry, this is in wind load in X direction. I'll have this in X direction, 0. Okay, and I'll add for the Y direction. So the load case name will change to WLY, and here I'll use the IBC 2012 wind speed 160 into 0.63, gust factor effect, calculate, okay, and wind load direction 0 in the X. I'll click on OK, and we have got WLX and WLY created. Close. Similarly, we are going to be applying the seismic loads now onto our structure. So we'll click on seismic loads, click on add. EQX is the load case name. I'll select UBC 97. Provide the parameters now, the seismic load parameters, which include the soil profile type. So I'll have SD. Seismic zone factor I'll take as 2B. Importance factor I'll keep as 1. Now the structural parameters that we have to provide is the period basically. So period as per the analysis type, that is after we perform the eigenvalue analysis we can provide the periods right over here, or we can go for the method A as per the code and use the period calculator. We can provide manually, however we can use the period calculator by the software, and for the moment resisting frames we can use the second formula. I'll click on OK. The software has automatically calculated the period in the X and Y direction. Further, the ductility coefficient I'm using 4.5 in the X and Y direction. Seismic load direction factor, just like we had provided earlier for the wind loads, here also I'm going to provide the EQX load case for the X direction and Y direction will be 0. I'm not considering the accidental eccentricity, so I'll click on none. And further I can click on the seismic load profile to see the story forces, story shears and overturning moments. So even before analysis I can get to know what is the story shear. It's 3327.774. And just like wind calculation sheet, I can have seismic load calculation sheet. I'll click on apply and create the second seismic load profile for the Y direction. So the X scale factor will be 0 and the Y scale factor will be 1. All the rest of the parameters are same. I'll click on OK and close this dialog box. Close this dialog box again. After providing the lateral loads, I'll move ahead to the floor loads command. Now we know that we have not created any slab model as such. There is no plate elements for our slabs. This is because, as explained earlier, we are having this as a rigid structure with every floor as a rigid type, and therefore we have considered the rigid floor diaphragm. So how to apply the floor loads? How is the floor load going to get distributed on our beams if there are no slabs that we have modeled? Well, the answer to this question lies over here. The assign floor loads command is the one to do the load distribution. So let us see that now. There are two simple steps for that. Simply define floor load type first, in which you can include all the load cases at once for the particular area. We'll see that now. Let me provide one floor load type. I'll call it as floor load. In here, as I have not modeled any slab, so I have to provide to the software here the self-weight of the slab. I'm considering 125 mm thick slab and 25 kilonewton per meter cube as the density of concrete. So I'll provide here minus 3.125 kilonewton per meter square. Further, the load case name, I'll put a dead load, which is like my floor finish. So I'll provide minus 1 over here as my floor finish, and my live load as minus 2.5. I'll click on add. Now every area is going to have a separate floor load, right? So we can create more number of such type of floor loads and we can apply it onto each and every area. So let us see how easily we can apply these floor loads on the areas. So I'll close this dialog box. So go to assign floor loads. So here the command is opened up in the left tree menu. I have selected the load type which I just created. The distribution I want it two-way. Then I can have the floor load two-way distribution not only to a rectangular slab but of any shape, but for nodes. No, but for any shape, so I can check this on. Further, I can copy this particular floor load area onto the upper stories. So I have got this typical floor load from the lower story to the upper stories. So I can simply say copy floor loads and provide the distance. So I am going to exclude the roof. The roof is going to have separate. So let's say I'm providing the 17 numbers of stories above my first floor at 3.5 meters. Now to apply the area, I'll have to activate one particular floor. For that, I'll go to the activities tools over here, in which I'll select the activate by identifying. Here I'll select the stories that we had generated and I'll select the second floor, this 2F, that is the first floor actually. So I'll just select the floor here and click on active. I'll close this dialog box. So as you can see over here, only the second floor is activated. Now I will click over here to define my loading area, nodes defining loading area. 2, 3, 4, 5. So here we go. This is the load distribution. So basically the software has firstly created a dummy slab, then distributed the floor loads, and then removed that slab. So this is how the distribution is taking place very easily in the software. Similarly, I'll do it for the rest of the area. As well as over here. And here. This is one-way distribution. Two-way distribution. I can go ahead to the one-way distribution now. For one-way distribution onto the longer beams, I have to start with the shorter side. So I'm selecting the shorter side. That's it. And my loads have got distributed by one-way type to both the longitudinal beams. So if you look at the entire structure, I'll activate the entire structure. The loads have got copied easily onto the upper stories. So I'll close this dialog box now, this command line. And we are done with the static loads. I'll go ahead now to the dynamic loads. In the dynamic loads, we're going to perform over here the response spectrum analysis. So the response spectrum can be performed using these two simple commands. Firstly, define the response spectrum function and then define the response spectrum load cases. So firstly, I'll click on the response spectrum function. I'll click on add. Click on design spectrum so that I can select the code similar to the static load case, so UBC 97. Then seismic coefficient calculations would be automatic. The soil profile type to be selected is SD, zone is 2B, and over here CA and CV are automatically calculated. These are the coefficients. And then upon clicking on OK, the design spectrum has been automatically created. And this is the data, the spectral data automatically generated by the software. Here you do not need to provide any scale factor. We'll click on OK and close. Let's go to the response spectrum load cases. Here I'll provide the name as RS major to provide the response spectrum at the angle that will provide me the maximum base shear. So this the software can automatically do by checking on the auto search angle. the major angle. Here the scale factor I'll provide as I by R because those two were not defined at the time of design spectrum. So I'll provide over here the value I, that is 1 divided by 4.5. The period modification factor will provide after the analysis. We'll click on the function name to be used and then click on add. Similarly, we'll create the second load case for the orthogonal direction by clicking the auto search angle as the ortho. Rest parameters will be same. I'll click on add. So we're going to be performing the eigenvalue analysis for the response spectrum. The modal combinations are required, so we'll click on the eigenvalue analysis control, and here we have got eigenvectors as well as rich vectors, 54 number of frequencies, and the subspace dimension in that case will be double of that, so let's take it as 108 and we'll click on OK. So here we go, we have finished with applying the static loads and the dynamic loads, and also we have applied the eigenvalue analysis control. So we're good to go ahead and perform the analysis. Over here at the bottom in the message window, we will get to see the analysis message, any errors or warnings if any. Within few seconds, the software can perform the entire static as well as dynamic analysis. In the analysis message window, as you can see, within 15.4 seconds, our entire structure has been analyzed. There is no warning or error as such.